Welcome to another episode of Code for Thought. My guest in this episode is Teresa Gomez-Diaz from the University Gustave Eiffel just east of Paris. Teresa has been valiantly promoting open science for a long time and trying to establish research software and data as equally important research output together with traditional publishing. In fact, only last year we spoke on this podcast about the importance of software licenses in research. But open science is an umbrella term that covers not only open software but also open access and open data in all its different aspects. Defining use cases and the use of open software and open data, proposing policies and practical steps to implement them has been an essential part of Teresa's work together with her colleague Tomas Recio from the University Antonio de Nebrija in Madrid in Spain. The reason we met in Paris in April 2023 is that Teresa and Tomas published a paper in F1000 that defined research data and their use. In a second paper, they take that definition and propose a protocol called CDUR that aims to help researchers evaluate their contributions along open science principles and policies, including FAIR. The papers are available in F1000, as I mentioned, or mille, as Teresa mentions at the end of our discussion. The Francophone listeners amongst you will notice that the acronym CDUR can be pronounced as CDUR in French, which in English means it's hard. And hard it is to change the mindset of researchers, policymakers, publishers and funders to regard research data and research software as equal citizens in scientific output. Luckily, progress is being made and we see changes emerging in many places. For instance, there's an initiative called Hidden Ref and also initiatives to make software more citable. But before we go into all of that, here are a couple of announcements. We'll be slowing down with podcast episodes for the month of August 2023 and start again in September with a very busy season 6 of Code for Thought. September and October, of course, will also see, as previously mentioned, a number of RSE-related conferences in the UK, Germany and the US, and you'll find the details in the episode notes. And now, and without further ado, my conversation with Teresa. Hello, Teresa. Good to see you again.
Hello, Peter. I am very happy to see you again. Thank you for coming here.
Yeah, no, it's a pleasure. It's a bit of a grey day in Paris today. Unlike last year when we met, it was
sunny day.
A very sunny and very hot day. So some listeners will probably remember you from last year, but perhaps you can quickly introduce yourself again.
First, thank you for giving again this opportunity to talk about my work with Professor Tomas Recio. So I am Teresa Gomez-Diaz. I am a Spanish person, a French research engineer. I work for the CNRS, but I work at the University Gustave Eiffel. That is a new university, a recent university that gathers some different establishments and universities already existing. We are in the process of fusion, of making this together. And I work at the Laboratoire d'Informatique Gaspard Monge. That is a research lab.
The reason we're meeting and talking today is because you've published together with Tomas Recio, who I met actually at the workshop last year, and you and he organized the workshop on open science. And you published a paper, well actually 2 papers as I said, about research software and research data. The first thing that I noticed was something actually I didn't know at all, and it mentioned something called the Borgmans Conundrum. And I don't know what that is.
So Bernmans is a woman, a researcher that works on research data since long time. And she's very well known in the world of research data. And at some point she said, this is very difficult. To share research data is very difficult. And set the questions, the initial questions. Which research data might be shared? By who? With whom? Under what conditions? Why? And which are the effects? what we are expecting of this sharing,
Mm-hmm.
of these research data sharings. And there has been a lot of work. It's a difficult question. And with Tomas, we think that we have been provided context in which we can have no easy but answers to these questions.
All right, so the conundrum really is the difficulty in defining research data, what it is, who it's for, what purpose it serves, and the sharing.
Why to share it?
And why to share it. And you're linking research software with research data. And as research software engineers, we sometimes feel intuitively, yeah, it works. But could you explain that link explicitly, what that is?
Okay, so the question is that I work in research software since a long time. With Tomas Recio, we also wrote a paper on research software, give a definition and also an evaluation protocol for research software. I have been working a lot in this lab about how to disseminate research software, what is it, how you should deal with it. And in fact, in this work of research software, when we look to problems for research data, we can say this is the same.
Mm-hmm.
And so we can provide the same kind of answers. So, for example, which is the link? The link is that there are similar problems for research data and for research software.
Okay.
One of them, which is very important in the scientific world, is that at the moment, as far as we understand, there is no a real publication protocol as the one that exists for publications, for articles.
You mean publishing software or including software and data in publications or as a standalone?
Publish it. You publish an article, how you publish a research software, how you publish a research software, how you publish a research data. There are journals, there are data papers, there are software papers, but this is still ongoing building framework. There are, for example, scientific areas where all this is much more accepted, but the publication protocol doesn't exist for everywhere as for articles. And another question is evaluation. Most of the research work is evaluated only for publications.
Yes.
Now things are changing, but it's a difficult change, and it will take time. But we are on it.
Okay.
So our work in the work for research software and in the work for research data, we think this problem is the same. We can build this framework in which we can provide similar formulation for research software definition and similar formulation for research data definition. So we can answer to some questions, for example, dissemination, for example, evaluation.
So you already talked about the difficulties of defining research data, initially with the Borgman's Conundrum, but what specifically are the difficulties in defining them?
Okay, so what we can see in our work is that we can provide a research data definition. And the difficulty is not in the formulation of this definition, the difficulty is in defining data. Data is a very complex object, extremely complex from many different points of view, from scientific point of view, from the legal point of view. It took us time to see. For research software, we have given a definition, but we didn't try to define software.
Okay.
Because what we took initially, and since long time, we took the legal context. Because what is important is the authors and copyright law. So in the scientific world, this is very important. And so we adopted this legal context. Once we understood it, we say, we don't define software, but we define research software. It also takes a mathematician like Tomas for this kind of things. And it took time for data. Data is a very complex object. So when you see, I have been in a lot of conferences, and you see all this is very difficult. How do you say what data is? We don't.
Okay.
But we can say what research data is.
Okay, so basically a subset of this whole huge pool that data is, you pick, say, okay, we only focus on research data and narrow down the definition for that.
What we say is that our problem is not to define data. Once that a research team is working in some kind of specific data, we say what is research data and how you should deal with it. The data should be studied in a case-by-case basis, from the scientific point of view and from the legal point of view. Once the research team is working on this, you say what is research data.
Okay, because research teams can actually create lots of data. Some of it, or most of it, is research related, like in a biology laboratory, you create data through measurements. But they also have lots of administrative data. But you say, well, this is basically falls outside the scope.
It is not. So when we wrote these two papers with Tomas, we say research data is the data produced in a research context by a research team. And some people say, no, this is too narrow. And in fact, it is not. For a paper, for an article, it's very clear what is a research paper, and that everything published in a newspaper is not a research paper. It's not a research publication. And this is very clear for the whole scientific community, and there is no problem in the scientific community for this. But this doesn't mean that researchers don't go to newspapers to find information.
Okay, yeah.
It's not a scientific publication, but it's information that they can use in their research. And with data is the same. For example, you can produce some data in a lab with an instrument, but a sociologist can have need to go to historic resources or to administration resources, and they will use this information, but they will select the information. There is a research process. This is the vision of research software.
Okay.
One thing is the software that you write in a lab, and this is research software because you are trying to answer a scientific question. But you may use this component that is already there, and maybe you take it and you integrate in your software, or maybe you will modify it. So you should say, well, this is my software, and this component comes from here, and this component is from here, and maybe this component is research software, or maybe not. So when you are doing your software, you are putting a lot of different things together, but you should say which is yours, and which is the research production of others, and maybe other components. When you do a publication as well, you say in the references, I have used this work, and this work. This is the vision we have in software that we put clearly in data. What is the data that comes from your work, and which is the data that comes from other places, and how you use it, and how you mention this work, scientific or not. And you can do this reuse because there is a license that allows it.
And we talked about licenses last year, that I remember that, yeah. What are the difficulties? You alluded to that somehow, but what are the difficulties in the current definitions of research data? So, for instance, your paper mentions explicitly not only, but also the definition by the UK Research and Innovation, UKRI. So where do you see the problems in their definitions of research data?
Okay, so this is the definition provided in a document that is signed by the UK Research
Innovation
Institute. So research data are the evidence and that underpins the answer to the research question and can be used to validate findings regardless of its form. For example, print, digital, physical. This might be quantitative information or qualitative statements collected by researchers in the course of their work, by experimentation, observation, modeling, interview of other methods, or direct from measurement or collection, or derived from primary data for subsequent analysis or interpretation. All this is complex, and the complexity is in the data. The scientific work is clear. we like to answer a research question. But in this definition, who answers the question? So if we come back to the Christine Borgman's Conundrum questions, with this definition, there are things which are unclear, which is the research team. If there is a scientific question, which are the publications related to this? So the problem is that.
Well, which brings us to, what is your definition of research data?
Okay, so I should read again.
Yeah, indeed, exactly, because
Yes.
that's going to be a longer paragraph, isn't it?
Yes. So the research data definition proposed with Tomas is the following. Research data is a well-identified set of data that has been produced, and produced means collected, processed, analyzed, shared, and disseminated by, again, a well-identified research team. The data has been collected, processed, and analyzed to produce a result, published or disseminated in some article or any scientific contribution. Each research data includes a set of files that contains the data set that is maybe organized as a database. It can also include other elements as the documentation, specifications, use case, any other useful material, information about the instrument that has produced the data. It can include information on the software that has been used or is necessary to manipulate the data, and maybe this software also comes from research teams. In the set of files, you can include any information that is necessary to help others. So the first thing, identify the data set. The second thing, identify the persons, the team. That when you say collected, processed, analyzed, shared, and disseminated, there are maybe different roles, not only researchers. So the goal is to do research. It has been produced by a research team, and the results are published. Maybe the publication is ongoing, or maybe it's a long project and there are several publications. But the identification of these three steps are the basis of our work. And this formulation comes from the research software.
Oh, right, okay. So
this is the formulation.
Yeah.
The team, what they do to answer a scientific question, and the results are published or ongoing. In this context, the questions of Bernmans Conundrum find easy answers.
The crucial element is it's not just about research data, but also who produces and publishes them. So the definition, tying that to the people who are involved in that process of creating and publishing.
Yes.
And
the question is that there is no a real scientific publication. It's a dissemination. In fact, we had a dissemination protocol for research software. What should be done before you give the software away? Identify the users, put a license, have all the intellectual property well clarified. I said since long time, this protocol also is useful for data. But until I had the formulation, you need the definition.
Your paper also mentions the CDUR principles, and I'd like you to explain what they are.
Okay, what you call CDUR, we call CDUR.
CDUR.
Okay. Sorry, it's French. In fact, when we did this work with Tomas about research software, the very, very important thing is how you give value to this production. Because, for example, with Tomas, I come from the computer algebra scientific community a long time ago. And now I am here in a computer science laboratory. And in both communities, there is a lot of software production. A lot, but really is very important. Has never been evaluated.
Because the only thing you ever see is the paper.
What you look is the paper. So when you do a software, the first thing was to write the paper that says what the software does. But the software is work. It's a lot of work.
Well, actually, it is the work, you can argue.
Many times. So what we said is it's important to propose a protocol for evaluate this object. And the first step is citation. That means that the object should be well identified. The title, who has done, where it is available, The second point is the dissemination. It has been given away to the scientific community correctly with a license. And then we have two steps, use and research. The step use looks at all the difficulties on the software side. And you can go as far as you like in the quality of software, in many different things, quality, documentation, testing, protocols, etc. But it's research software. So the first thing is the answers to the scientific question are correct. And the fourth step is the research work. Then you look to more theoretical aspects of the research work that has been done with the software. The publications, the quality of the algorithms, the collaborations, the projects you have been able to build around this software. So these 4 steps are the same for data.
I was about to say, because that is again sort of where you see the similarities between the software production and the data production.
The first one, citation. The data should be well identified. Who has done it? Maybe there is some intellectual property or maybe not. The dissemination, how the data has been disseminated, corresponding to some open science policy, for example. In the use step, you put all the complexity of data. Quality. In the research step, you put all the complexity of research. So the protocol is the same.
What I find surprising, because the discussion about this protocol, but also FAIR principles and open science, isn't exactly new. It's not like we created that last year. It's been around for a while. But it still seems to be a problem, doesn't it? So how big a problem do you think it is? Why do we still need to go on?
The problem is still big. There are a lot of researchers that know more or less the open science context, the FAIR principles. But once you have this more or less general knowledge, how you apply it, how much work you should do to comply to open science policies. For example, if you have European Commission funding for a project, the context of open science is very clear. What you should do to comply. If you don't like to comply, it's possible, but you should explain how, why, etc. The context is very clear for this funding. But maybe other fundings don't ask. This open science policy is not so clear still. If it's not clear, why you should care?
Yes.
Maybe you know the FAIR principles, but it's something that I should do, or others should do, or others should provide me the infrastructure where I can make my data fair or my software fair. This is still not very clear for many researchers in many different areas. But the main point now is evaluation. If I should do work for this, how it will be evaluated? If not, I don't care. If no one is going to tell me you should comply with this open science policy, then your career will go much better, or it will be easier to have funding. Why I should care? So evaluation is a very important step. As far as I understand, in Europe, it's clear that the evaluation system for research should change. It's very clear. But how? In which way? And you cannot change the system. For example, in Spain, all the impact factor of publications is very important. These are national committees that look where you publish, which review, which journal, which impact factor. And you cannot change the system in 1 year or even 2 years. Right now, there is this COARA coalition. COARA means the Coalition for Advancing Research Assessment, because there is this understanding that it's a big problem and we should change it. There is a coalition of many universities to study the problems and to propose solutions. And this can give a context widely accepted in which the change will be easier to adopt and to be adopted by many researchers, by many institutions. But it's a very difficult work.
There's quite a lot that depends on it. First of all, what are the principles for evaluation? What kind of framework are you using? Let's say somebody evaluates a paper in Spain and then somebody goes and sort of evaluates a paper in Norway. Are they using the same principles?
What I can talk is about Spain and in France. In France is different. In Spain there is a very impact factor system, national system. In France, no. In France they try to do some kind of factor system. And they understood that it's the French spirit as well, liberty. So it was not possible to find a system. But what we propose with Tomas is a protocol that answers real questions. We don't know if this will be adopted or accepted by the Quara coalition. Everyone knows that we should take care of other research productions, not only publications. And we say how we propose this CDUR protocol. What we should understand better, still we did some work in the papers we are talking about, is the relationship with FAIR. We propose something, but we think there is some work still necessary.
The evaluation to take different forms than traditional papers, there needs to be additional evaluation processes in place. So for instance, citation, we have citation of software and citation of data. And there are some steps, however, that we've already taken, because there is, I think, a way of including software citation now on a GitHub repository. So I think Stefan Druskat from Germany has done a lot of work of that.
Yes, he did the citation files, software citation files. So first step is citation, but then we should also look to the other steps.
Exactly. So I mentioned that as a starting point. So what are the other steps and what kind of practical adaptations or tools do we have in these areas?
We have proposed this dissemination protocol for research software and for research data. That is also valid for research data. We say the protocol is the same, but there's a step that says be careful with legal issues for data. Legal issues in software is mainly related to copyright, to intellectual property. In data can be very complex. It can be very simple. Mm-hmm. If you say the temperature in this country since the 2 last years is like this and is evolving like this, there is no real legal problem. But data can have intellectual property, data can have personal issues, medical data.
Okay, yeah.
So the data can be very complex.
So, for instance, if you have medical data, so you do medical research and you have hospital numbers and addresses of patients, etc.
What we say in the dissemination protocol that we propose for the research data is, in this step, before you give the data away, you should take care of the legal issues. We don't say how, because the legal framework can be too complex and you really need legal experts. If you like to give this data away because it's necessary for other studies or to validate your studies, take care of this legal point in here.
It's an interesting question, and particularly in life sciences. And the reason I'm mentioning this is that we have a lot of research that is publicly funded, but we also have a lot of research in life sciences that is privately funded.
Yes.
For instance, pharmaceutical industry that produces new treatment that then needs to go into medical trials. And the data obviously need to be shared.
If you like to validate or provide the way that others validate your research, the data should be somehow available, maybe in a private context, maybe to give away to everyone, or maybe to say, if you like to study this data, come here. But if you like that others validate your research work, they should have access to the data. Sometimes you can say, well, this is a research result, and other people come from other theory and say, yes, I understand that this is valid. But sometimes you really need access to the data or to the software.
France has legislation to make research software and data, and that's a question mark really, because I'm not sure about that. But research software, at least that's publicly funded for publicly funded projects, they have to be open source. Does the same hold for data as well? Does that have to follow open science principles in France?
The legal context in France is clear for data than for software. In France, there has been this law, the Digital Republic Law, with an article that established new duty for universities and research performing organizations. And there's this Article 6 that says open data should be the default for all publicly funded data, including research. So if you have a project that is publicly funded and you have produced data, this data should be open. The law has been followed by political documents, the Plan National de la Recherche in the Minister of Research. There are two versions. The first one spoke about publications and data and open science, and the second one also includes software and established the political context in which publications, software and data should be publicly available.
So you've been in France since 2002. Do you think that these laws have helped? Do you see actually a real change since the introduction?
There is a change, and there will be more changes. For example, the ministry is currently launching an enquete survey about research software at the level of the ministry. This was unthinkable 20 years before. So things are changing, things are evolving in France. For example, the CNRS, the Centre National de la Recherche Scientifique, is telling right now that more than 90% of our publications are open.
And the reason I'm asking this question is because we're really talking about a mindset change. And I wanted to see, since France introduced legislation, how much that has helped.
For publications, I think it's pretty clear. There is no question now at the level of institutions. There is still work to come, but we have the right infrastructure to make publications open. So when you publish somewhere an article, you can put the published version in this infrastructure. For data and for software is still work to come.
The final question that I'd like to ask you is, all this work that you've done so far, bringing the worlds together of research data and research software, defining protocols, how do you promote, how do you continue promoting your work?
Well, thank you to you, for example. Well, this is very recent publication. The research data work has been published last year. So now we are entering in this promotion work where we will try to go to conferences. There is very good news from last week.
All right, okay.
Yes.
Hot off the press.
Yes. So all these three articles with Tomas, they have been published in mille publication journal. And there is a new section, which is called Innovations in Research Assessment Collection. And we have proposed that our three papers appear in this collection. Thank you, Simon Hetrick, and another person, I don't remember his name, from Canada. We thank you them because this will give more access to this information.
Excellent. Thank you very much for this interview, Teresa, again. No doubt we will talk in future for future podcasts.
I hope so. I hope so. Thank you very much because it was very interesting to prepare all the interview. I also hope that we will talk further more about all this work and many other things.
Yeah, well, the work will continue, as we know. And
I hope so.
Okay.
Thank you very much, Peter.
Thank you. Thank you. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.